Good evening, everyone. Thank you for joining us today. I'm Shama, Manager People Solution at Kadel Labs, and it's my pleasure to welcome to another session in our Expert Insight series, Kale Tech Talk. At Kadel Labs, we believe in sharing knowledge that drives innovation and transformation, and we are thrilled to bring insightful discussions from industry leaders to help professionals like you stay ahead of the curve. Let me give you a quick overview of who we are. Kadel Labs is a first of its kind venture studio in India, a global software technology incubator with a synergistic blend of IT services and SaaS products in its portfolio. Since 2017, we've grown to 180 plus employees, served 200 plus customers worldwide, and built a global presence with operations across multiple regions. Our work spans fintech, health tech, edtech, retail, insurtech, manufacturing, and telecom. Our expertise lies in cloud engineering, data analytics, software development, and AI services. At Gate Labs, we take pride in being a people centric company, fostering creativity, free flowing communication, and continuous innovation to build better products and services for our clients. Today's session is part of our ongoing effort to bring cutting edge knowledge to the community. We are delighted to have Vamsi Chittoor with us present an exciting topic, LangChain webinar for dummies. LangChain is revolutionizing the way we integrate AI-powered applications into business workflows. In this session, you'll learn about LangChain operations, integration strategies, and hands-on code examples to develop smarter AI applications. Whether you're a professional or a tech enthusiast, this webinar is for everyone interested in leveraging the latest AI tools effectively. So today's key takeaways would be understanding LangChain and its operations, develop smarter AI application and LangChain, implement LangChain effectively with practical examples and key features. We encourage participants to actively take part. Drop your questions in the chat, or we also have a Q&A section, and we'll address them towards the end of the session. So once again, thank you everyone for joining us today. So let's dive right in and explore the fascinating world of LangChain with Vamsi Chittoor.
Thanks, Shama. Welcome everyone to today's webinar on LangChain for Dummies. So to introduce myself, my name is Vamsi Chittoor, and I'm excited to share my experience with this powerful open source framework, which you might have heard when you are talking about LLM. So ChatGPT, Llama, what are all the things that are going currently in the market? So everyone is trying to learn large language models, but in the backend, there are a lot of tools that are making the interactions between those large language models versus the actual systems more easy and smooth compared to doing everything by yourself, making it hard to implement the systems which require high level of integrations as well as high level of database connections and parsing everything. The LangChain is the one which is trying to sit in the middle of all these operations and trying to help you do the tasks much better. Now, the agenda for this particular session would be, we'll be looking into what is LangChain and whether the LangChain is a Python library, how does it actually help developers, and why should we learn LangChain? What are the top key features of LangChain, and how actually LangChain works? So we'll try to see a flow diagram or understand like actually where does the LangChain sit in an application powered by large language models. And also to give you a starter confidence, we'll try to show you an example code where we try to show you how do we build a simple application using LangChain. How do we set up the large language model? For instance, currently we can use LLMs, which are like OpenAI or something like that. And also we can use a vector databases, which is again another big tech behind LLMs. So we try to use a sample code which uses Milvus in this particular demo. And then we will try to summarize everything, and then we'll give you a chance to do the Q&A and any questions that you might have while you're trying to actively explore this particular technology, or you're trying to get into this technology, or even if you are a starter in data science and trying to explore like what are the trending technologies that might be giving you a great salaries as well as freelance opportunities, because there is a imbalance between the technology improvements versus the people who knows these technologies. So that is where this webinar is trying to give you more confidence to enter these arenas. Now, what is LangChain? people are hesitant to use any paid applications, right? If you build a framework but it is paid, people are less likely to adopt that into their systems. But the promise that the LLMs and LangChain have is that there are open source alternatives as well. LangChain is an open source framework for large language models. It helps ship large language model applications faster and easier. And also, it is just not a tool that helps you to connect with LLMs, but it is also having a set of standardized tools. Let's suppose there are tools which helps you to connect with external databases. It has some abstractions, set of abstractions which helps you to extract or parse different set of files. Let's suppose you upload a PDF and in a chat GPT or anything, it's going to extract the text or images, or it's going to do some kind of extraction. So in the backend, so you can use LangChain to power that particular kind of operations as well, and with ease. So it gives you some abstractions, which means you don't need to do things from the scratch. You already have set of tools and technologies built around LangChain to implement in your workflows. And it enables you to focus on the actual logic instead of trying to build the blocks. So you focus on the high level application logic and the background task and background processes. The LLM helps you to do that. So if you see here, the LLM, basically, if you talk about LangChain, so this is sitting in middle of all the different processes. If you talk about the very important processes or set of operations or components of the LangChain, you have documents. Obviously, anyone who is trying to use LangChain or LLMs, obviously they have a set of questions, and in most people want to ask questions about their specific documents. The LangChain comes up and says, hey, see, I have a set of abstractions and tools. You don't need to write the whole code to extract data. Let's suppose you're trying to deal with PDFs. So you wanted to extract the data from PDFs in order to ask questions about the data. Here the LangChain comes and gives you a set of tools which helps you to do that database connection. So you can connect with external databases and extract the data from PDF or any kind of files, Excel files, CSV files, or any kind of different files, which has like different set of functions which helps you to deal with different structures. And additionally, you might have already heard something related to prompt. Prompt simply is a set of instructions that you give to the LLM in order to execute a particular task. Let's suppose you take a particular sentiment analysis. So you say, okay, if the person is talking positive, confident, or something very interesting or exciting, you can classify positive sentiment of the person. If the person is talking negative and something low in voice, less confidence, something. So these are the instructions you're trying to pass to the large language model. ChatGPT, for instance, everyone connects with this particular word. ChatGPT, everyone knows about it. When building a large language model application, you write prompts to solve a particular problem. LangChain simplifies prompt management. So there would be a lot of prompts, right? So you technically have a different set of questions. So each question from the customer would be different and the use cases would be different. But there would be a standard set of blueprints which helps you to only focus on the prompt and leave the rest of the integrations, like how it's going to be working in the background to communicate with the LLM and get responses. Most tasks, uh, LangChain will help you with ease, right? And the next part is chains, right? So chains are simply, if you take, it helps you to connect multiple large language models in complex applications. Let's suppose if you take a very big application, you have a multiple set of reasonings that are required, and you wanted to chain them together to get the final output. First, the output of the first language model might be the output to the second large language model, and so on. So you can chain as many large language models as you wanted. But if you take it like a raw set of tools and technologies, so you might need to do all that chaining by yourself. You need to maintain consistency and and also maintain that there is no problem with respect to the communication or the way the output through different chains. Here LangChain comes and helps you. And the next thing is LLM. So LLM is like a brain. So if you in olden days you are talking about computers as the brain. So CPU is the brain of the computer. Similarly, LangChain technologies revolve around LLMs. LLM is the one which is gonna be the brain of the LangChain ecosystem. where you're trying to derive the outputs, or you try to ask questions and get the answers based on the documents that you're trying to pass it to the LLM. Agents are more or less something close to chains, but there are a few differences, right? So agents, if you think about it, so they have more reasoning power. Sometimes some complex applications, you really don't know what are the set of tools or technologies or workflows that you need to implement. But there are some standard agents, even you can build an agent for yourself. So they have that reasoning power. So based on the problem statement you're trying to solve, right? So they helps, it itself tries to pick those set of technologies or tools that it has access to and try to solve that problem. It has more freedom to solve problems compared to chains. Chains are a fixed set of instructions, output 1, output 2, output 3, and it's the same every time. Agents have more flexibility. Now, coming to whether large language models are revolving around LangChain, but whether LangChain is a Python library or what are the different languages does LangChain have support for currently, right? So if you ask whether the LangChain is a Python library, yes, it is a Python library, and you can install it using Python installation manager, so the pip. And also currently the work is in progress, like people are all around the world are trying to extend the support to other languages as well. But as of now, the top three supported languages are Python, which is the very first one and the most flexible and most powerful language supported by LangChain. And also there is some level of support for JavaScript and TypeScript as well. Specifically, it helps you to implement LangChain processes and applications on the web development side. So you might have heard about the Node.js ecosystem, Node.js environments. So there it has a level of, it may not be equal to Python, but it has certain functions, certain level of components that you can still work on website as well in the Node.js environments. And if you ask what are the different set of operations that are supported in Python using LangChain, you can do transcriptions. So there are set of tools that helps you to transcribe, and you can also do search. So while you have a vector database, so we'll come to vector database and I'll give you a brief what are vector databases as well. But if you have a vector database, you can actually search through your documents and you can extract the relevant documents from the vector database. So let's suppose you upload a big PDF and want to ask questions to that particular PDF. So the way it works is you are gonna vectorize. So vectorization in the sense you're trying to convert the PDF or text format into numerical format, and the database which stores the data in vector format. Vectors are a set of numerical arrays. SQL stores data in tabular format with the actual text numericals, or these are the there are different data types, right? And if you talk about MongoDB or any other thing, so they still have set of different data types, and they store unstructured, structured data, semi-structured data, all this kind of data. And besides that, this database we are talking about is a database specifically used for storing embeddings, which are powered are most important for LLM applications. You can design prompts in Python, do caching and embedding. These are top operations supported through Python. How does it help developers? If the tool doesn't help, or if it is very hard to maintain or hard to integrate with other systems, it would be of no use. So first thing is it helps you to combine multiple LLMs together for some complex tasks. So there are, if you go to actual industrial applications, a single LLM won't be solving the issue. So you might need a set of LLMs, at least 3 to 4 different LLMs, which are integrated together. As I said in the past slides, you are trying to solve each different reasoning task or set of instructions using different LLMs, and you would again have another LLM which takes the output of these LLMs, which are intermediary, and gets you the final output. So while you're working with this level of complexity, this level of integrations, this level of intermediary steps, so this LangChain helps you to just make that process quite simple. So there would be only few lines of code Using those few lines of code, you are doing all this multiple LangChain, multiple LLM integration quite easy. And the second thing is it helps you to manage the prompt easily. So prompts are simply the instructions, and it gives you set of libraries, set of functions, which helps you to do some prompt construction quite easy. You just need to pass the few variables which are defined by the user as per the question. But apart from that, rest of the prompt, you can. Is there any question? Rest of the prompt you can define using LangChain. And also you might have heard, so any LLM application, let's suppose ChatGPT or anything, you might have heard that there is some kind of memory. So when you are asking a question, if you start asking a question to the ChatGPT, after a set of questions, after a set of instructions or conversation, it knows what exactly you're trying to ask, what is the context, and it gives you the output with respect to relevant questions you're asking. So this is where comes the conversational memory of the LLM applications. So the conversational memory is simply you start the chat with the LLM. There would be a to and fro between the user and the LLM. So you ask, suppose, what is the temperature in Bangalore on this particular date? The LLM tries to give you a response, and then you're asking what could be the reasons for low temperatures in Bangalore. Or let's say you skip Bangalore, but you're just asking what could be the reason for low temperatures. So intuitively it would have that background conversation, let's say a few messages from your previous history, and it's trying to look up. First question is why are the temperatures low? It doesn't know which city, but it has some conversational memory. So it has some set of messages which you have asked previously stored in the memory, which it is using as part of the context. It knows you are referring to Bangalore specifically. So now since it knows you are asking about Bangalore and you're asking about why are the temperatures low, it would have more contextual information and answer you with respect to that particular thing. Instead of trying to answer and give you hallucinations, it tries to understand it is related to Bangalore and you're asking why are the temperatures low. Bangalore is on a different altitude from the sea level. Because of that, there is low temperatures compared to other cities of India or other cities or other towns in Karnataka, right? So that's interesting, right? A LangChain also helps you to build agents for automation. Why you might have thought when I said the last time, so why do you build agents? Because you really sometimes you wanted to give that level of freedom to the tool in order for it to choose a set of different options, different appropriate tools available and solve the particular output based on what the user is asking. Agents come and they have that intelligence to choose those appropriate tools which are relevant for that particular inputs given by the user and then solve that particular problem. And this simple flowchart helps you understand how a typical flow of information or flow of the application works, right? So the user is gonna ask a question, and we know the prompts would be maintained and supported by LangChain, and there is a large language model one. So let's suppose there are two large language models in the typical application. So you are trying to store the history. So this is what we are talking about memory management, right? So you're trying to maintain a set of messages from your past conversation in order for it to make more contextual response. And then whenever a question is asked, so you're trying to retrieve the stored information and then you're passing it along with the final chain. So first large language model tries to make the new prompt to the large language model 2, and then the large language model 2 is the one which is going to generate the response, and you're going to display that particular output in the application side. So this is one typical flow that happens. So this is made such that you understand a typical flow. In most applications there could be only one large language model. Sometimes you don't need a memory module. Sometimes you need a vector database. Instead of just depending on prompts, you might get an additional component where you're trying to retrieve. Yeah, who is it? Sorry, I couldn't hear you.
Vamsi, please continue.
Yeah, the vector databases helps you to retrieve that relevant documents as well, besides the prompts, what exactly is coming from the user. And then why should we use LangChain, right? So by this time, without this slide, you might have already understood why should we use LangChain. There are a lot of easiness it brings to your development. It gives you standard and consistent abstractions for deploying LLM powered applications, for development as well as deployment, and for data retrieval. As I said, it has support for integrating with various set of applications or like vector databases, various vector databases. It supports retrieving the data from those different vector databases and processing integration. So as I said, there are different set of processes that between components of the LLM application. LLMs is one component, vector databases is one component. There are chains, there could be external API keys or services helping fetch data from backend to front end for developing, deploying data retrieval from vector databases, SQL databases, and MongoDB. Mostly you work with vector databases and processing integration. So LangChain is helping you to do them with ease instead of from scratch by yourself. What are the key features of LangChain? So if you see this flowchart, so by this time you understood like what are LLMs, what does a prompt construction means, and what is conversational memory, intelligent agents, indexes, and chain. Indexes might be new, but these are important words to remember and understand in order to understand where does LangChain fits in. Now the first thing, so I guess if you understand ChatGPT is calling an LLM model, but the model interaction is quite easy because the AI programmers are gonna interact with LangChain as a orchestrator, right? It's gonna be a kind of mediator which is gonna help you communicate between the large language models and the AI programmers. So it's like a standard interface. So standard interface, so the set of things, because it is standard, so there is a consistency between the different applications which are built around LangChain, and everyone can replicate the same application outputs and level of quality that is maintained. This is LangChain, and it is actually trying to coordinate between the large language models as well as the external data sources, Google Drive and Wikipedia databases, or even files as well. And prompt construction. So prompt construction is simply, as I said, prompt is simply a set of instructions to the LLM to answer your question. So in general, the prompt would consist of the question itself, what the question the user is asking, and also once the question is asked, you might retrieve the relevant documents from the vector database, which you have previously vectorized, right, and stored in the vector database. And then you're trying to ask based on this particular information or the documents, try to answer this particular question that is coming from the user. Now you have simple template, right? There would be a template. So template is like it has a fixed structure, proper structure. So there are few formatting options. So you format the input and the question or the documents dynamically into this template that is already maintained or supported by LangChain, right? So in simple, it is trying to simplify the process of creating and also managing the prompt templates, right? Conversational memory is something we talked about. So if you see here, whenever a query is coming, so it's trying to embed that query into a vector format. There is a vector database. So the vector database has the relevant documents which are previously vectorized and stored, right? Whenever there is a question coming up, so it tries to search. There are different criteria that you can use to fetch the documents. Let's say you can do one most popular thing is similarity search, right? So you do something called a semantic search, which is like a similarity search, and you try to see what are the top X documents which are very similar or very relevant for the question that is coming from the user, which is like a query. And then you try to retrieve, let's say I say five documents, top five documents based on the similarity score from the vector database. You use the template, input the current top five documents. The rest of the prompt template is fixed. Now, based on this content, you are going to pass to this particular, the content is going to be going there, and content together with the query, as I said. So the content is the relevant documents and the query is what asked by the user. And you can give some fixed instructions. Let's say you are a useful AI agent, very intelligent in solving this kind set of questions. You can give a set of instructions hard coded in the prompt, and whole of this thing, set of hard-coded instructions, current question, set of relevant documents, together gives you the final prompt, which you are passing through the LLM, and the LLM now have all the relevant information, relevant document, and any other information or other instructions that it needs to answer the question to the best of its knowledge. And it's gonna generate the output and then give you the response, which is gonna be coming back to the front end or application side. And then, as I said, so that is more like using chains, right? So in some certain applications, so instead of just trying to hard code the steps or hard code the prompt itself, so you can have an agent choose the appropriate tools for that task. It tries to solve that particular task at hand instead of trying to have a hard coded set of instructions or flow of data or flow of tasks, right? So here you can see the task is coming and the LLM is going to communicate with that. It's trying to reason first self loop because it's trying to analyze and understand, okay, this is the question, this is the expected output or expected task, and I have these set of tools that I can play with. Now how I can solve this particular problem. So once it understands, okay, tool number one, tool number two, tool number three. So these are the three tools that are required to solve this particular task. It identifies and tries to integrate or solve that issue and join them together and solve the problem by itself. So the tools, let's say there are 10 tools. It only chooses three tools, which means it is having that freedom to choose which tool it's gonna use based on the expectations from the user and action or the task he has given. Intelligent agents powered by large language models and LangChain comes in. And as I said, the next is indexes. So anyone who is having an experience with any databases, they might have known what are indexes. So indexes are simply a set of hashing. So you try to create some unique index. If you talk about SQL, there would be primary key, secondary key. These are helpful in those things. Similar to that, indexes helps you to retrieve the information from the vector databases faster. So whenever you ask a question, it helps you to make the process of comparing or calculating the similarity score between your question and the vector database documents quick and faster and tries to give you back. So this gives you some simple workflow. So you can see data ingestion. So it's going to be ingested and it's going to be stored in the vector database with indexes created. And then whenever you ask your question, so it's quite easy. So LLM is gonna work together with LangChain to retrieve the relevant documents, which is without indexes also you can do the task. But indexes simply makes your retrieval process faster, right? As simple as that. And then, as I said, so the key features of LangChain. So the last thing is like chains. So you might have understood by this time that certain applications really large language models have a context limit, right? So you cannot have infinite length of the document. Let's say thousand words or hundreds of PDF pages. You cannot pass all the PDF information into a single LLM model and try to get the response. So there is some limitations, including the uncertainty in the response as well as the context length. Context length is simply the number of words or tokens it can handle. If you take ChatGPT or any LLM model, so there is OpenAI models, right? So typically it would be from 4,000 tokens. Currently it supports up to 128K tokens for GPT 4.0, right? So GPT 4.0 and other things are like 32K. So there are various context length, right? And if you see map reduce, so map reduce is simply if there are 10 documents coming in, it tries to make 10 LLMs in the intermediary step, tries to analyze a set of documents by each LLM, and the output of each of these 10 LLMs is gonna be passed through, and the final LLM, it's gonna make the final response based on the response from these 10 LLMs. The refine is you start with one document and after each document pass it through the LLM1 and then you try to refine it based on you pass this output from the first LLM as context to the second LLM. So that now the second LLM has the documents, set of X documents along with the response from the first LLM. It tries to iteratively update the response that is generated. And once you reach the final chunk, it's going to be the final response that you're trying to pass to the application side. Map pre-rank is simply some little bit higher level of application of this particular thing, so which tries to give ranks. So instead of trying to do the thing, so based on the response, it has scoring criteria which tries to score the information or how much relevant is it for the question or something similar to that, and it helps you to get the final response based on, you can choose to get the top 5 scores and then generate a response based on that. By this time you already know this. So if you see, if you have given attention to our previous documents, you can understand there are document chunks which we are talking about all along. So which means you split the documents. Let's say a PDF document, there are 22 pages, 23 pages, let's suppose, as in our PPT. So you split that 23 pages PDF into 23 documents, and you store 23 documents in a vector database. That is like splitting the input document into smaller chunks, manageable chunks. Second is you are trying to embed these chunks into vector database, right? So embedding in the sense you're trying to convert the textual information into numerical arrays. There are Pinecone, Quadrant, and Milvus. Different databases are useful for different tasks in specific features. You generate the embeddings, and then you are going to store it in the vector database, which is like a vector store. And after the storing, you are free to ask the questions. So whenever you ask a question, so which is simply query, you try to retrieve the relevant chunks with relevant documents. So each chunk is a document, right? After you chunk and store in the vector database, you try to retrieve the relevant chunks and process using LLM. You pass the chunks and the question and any relevant instructions to the LLM, and it's going to generate the response. So this is the typical flow of how LangChain works in plain English. This is the visual representation. Take the PDFs, right? So this is going to be documents. You're trying to break the documents into smaller manageable chunks. You can see chunk 1, chunk 2, chunk 3, chunk 4. Let's suppose you split it into 4 chunks. Then the embedding conversion, you can see it's a numerical format, zeros and ones, right? It's converting into a vector representation, which is embeddings for the first chunk, second chunk, third chunk, fourth chunk. And you can store it in the vector database. So you can also store some metadata. So metadata is simply, let's suppose, along with just the document or chunk, you wanted to store which page it is coming from and the file. If there are 3 files, right, currently, you try to store it in the metadata, which helps you to retrieve and understand where the data is coming from when you ask a question. So you can store the data, name of the file, the date when you're uploading it, and which page it is coming from in the particular document. So a lot of things you can do it in metadata. And then once this is converted to embedding, and you're trying to do something called semantic search, which is like a most popular kind of matching the documents versus the question. And then based on the results are like a set of documents or set of relevant documents extracted from the vector database, right? Let's say 5 documents. You pass it to the LLM and the final answer is generated, and you're trying to understand it from the user. So user gets the output to the application. This is a simple flow to build a simple application. First, install the relevant libraries. So currently there could be a lot of libraries. So if you are working with Anaconda environment, so most of the important libraries would be pre-installed. So you might need to install LangChain because you wanted to have that interaction between the different vector databases and LLMs, all these things. And finally, you need to work with a vector database. Let's suppose we are working with PyMilvus, so which is again a vector database, and you are going to install those different dependencies which are required for the application. Second, you import the necessary libraries. So the prompt template in LangChain simplifies the maintenance and creation of prompts. Prompt is how you maintain the instructions and the context you're passing to the LLMs. So LLM chain helps you chain different LLM models together. And AI is simply LLM, right? So you're trying to use that as a LLM, and Milvus specifically is vector database, and OpenAI embeddings. So you are using this function to vectorize the documents as well as the query in order to run your application. And there are like OS, which is pre-installed, and it's used to get the paths and all these things. And PyMilvus is used to maintain the connections. And if you see, first of all, if you are working with open source databases or open source LLMs, you might not need to set any keys. But if you are working with any paid commercial um, LLMs, for instance, so let's suppose if you are working with OpenAI applications, so you need to set the environment variable like OpenAI key in order for the application to call the API and get responses from the LLM. If you see here, the prompt template, so you see there is input variable. What are the 5 most? And there is a formatting option. The topic is not hard coded. This is a simple example. You can build more complex prompt templates. You have a set of variables, tons of input variables, which you wanted to embed into the actual template. So the template initially has what are the 5 most curly braces topic, which is like a placeholder for the future topic from the user, cities in the world, right? So you see, it's as simple as that. You don't need to sweat. It's simply a prompt template. What are the input variables? What is the starter template? We are setting up LLM. There are different LLMs. We are saying, okay, chain this particular LLM, and you can see it is helping you chain the output. This you can see prompt is going to be passed to this LLM directly. So chain, right? So it is connecting the thing. So if you are doing it by yourself, you need to maintain those structures or interactions between those. So now you are saying, okay, LLM chain, and what is the LLM? What is the prompt? So you're passing it in the background. It's LLM. It's the LangChain task that it passes that prompt. Right. So when you call this LLM chain, it's gonna dynamically input the inputs from the user into this prompt template. Once that is done, it's gonna pass this prompt to the LLM, and this LLM is gonna generate the response dynamically instead of hard coded or a very complex way. It's quite simple. Currently, we are using Milvus as a sample and into the Milvus server running on port 19530 locally to generate the embeddings. Let's suppose the documents can be anything, right? Let's suppose these are 5 different documents. Each document is a text document. But for simplicity, we are just using a list of names of the cities, right? So you are saying like, okay, this is the embeddings generation instance, then instantiating the database. What is the function that needs to be used for generation of embedding, right? You're saying embeddings dot embed query. So whenever you add the documents, vector store dot add text, it's gonna call this embeddings dot embed query function and use OpenAI embeddings to generate the embeddings in the background. And the collection is like as in tables in SQL or collections in MongoDB. So the collection is simply here a set of vectors that are stored together in the vector database. You connected to the vector database, created embeddings, defined the embeddings and name of the collection, and added the documents. Now it's time to query. So you are saying like you are gonna integrate the vector database to store vector store and you're retrieve relevant documents. You're asking most populated cities. You are calling vector store dot similarity search of query. So similarity search. So it's just gonna find what is the top similar documents to this particular query. Right. As I said, so see LLM chain dot run and you're passing the topic, the placeholder in the previous prompt. The query is most populated cities. So you are calling from here and it has the relevant documents based on the query. It has the relevant documents and you're passing to the particular LLM and it's gonna generate the response. Right. And finally, I guess we are up to it. So this is how you can do an end-to-end application. So this is a simple application, but you can build on top of that and you can more complex applications where there are more than one LLM, two LLMs. And then you can also do extraction, right? So LLM or LangChain also has support for extraction of different set of PDF. So you can extract data from different formats of the files and you can connect with vector databases and generate responses across open source and commercial LLMs as well. So in summary, in this particular webinar, we have seen like what is LangChain. So LangChain is the open source framework for building applications powered by large language models. So it simplifies the development with modules for prompt construction, memory, and chaining LLMs. It enables users to create intelligent applications powered by chatbots and automated question answering. You can use agents to do some more flexible tasks by choosing tools relevant for the question asked by the user. And it also has like more support and makes the process easier for multi-step approach, integrating steps together, like from connecting to the databases to generating the response and streaming to the front end, right? Everything is possible. And it also has support for front end web development through TypeScript and JavaScript, and leverages vector store to store the relevant documents and use that as part of the context after retrieving based on the questions asked by the users. If you have any questions or doubts related to this topic or our current webinar, you are free to ask. Yeah.
So, what resources or courses would you recommend to our attendees who are students or interested in mastering this language?
There are a lot of documentation for LangChain. If you wanted to practice, so there are a set of things, right? So first of all, while you are trying to start with LLMs, so if you go to currently Anaconda environment has a new feature allowing you to play with open source LLMs. You can access different LLMs. And then related to LangChain, so there is a hell lot of documentation, official LangChain documentation, and they have a lot of examples on how to use it. And another important thing could be GitHub repositories. Since it is very new technology and there is a lot of tech going around this, so there are like very good GitHub repositories which have like end-to-end applications. Before understanding and trying to do this, so if you go to repository, simple starting from summarization, classification, complex applications, so you can go through the GitHub repositories. And also related to LangChain, so there are
Which industries are best positioned to benefit from LangChain and why?
so currently, as people know, so data science is spreading around every industry. So if you talk about LangChain, few industries are booming around it. So first of all, if you talk about support agents, right? So if you consider, if most of the times by this time most people would have experienced it. So there is a chat bot which is there in many of the applications, and it is currently powered by LangChain. Customer care, generally a person, a human person who is gonna talk to you and give you relevant responses. But while using LangChain, you can replace those agents, right? Customer agents with LangChain application. So whenever you customer ask a question, it gives you like a human. So it knows all the knowledge relevant for that particular question. It also interacts with empathy and emotional intelligence as well. So there are a lot of companies coming around that as well. And also there are industries related to edtech. So there is like personalized education. So whenever you ask a question, so you in the past you try to go to tuition or ask teachers about questions what you have, right? Currently, once you build a RAG application based on the different PDFs or different information that you have, you can ask questions. So whenever you are stuck at any place, so these specialized RAG applications helps you to make your questions resolved then and there, and even help you to learn faster. And also there is some set of experimentations going around personalized learning. So basically not every person have the same capability to learn in the same way, right? So there are applications which are trying to solve that issue, like based on how the user is learning. So it tries to change the way of pace at which they learn, or help them understand like what are the different things what they can learn, so what they can focus on. So something related to personalization. So if the person is weak in a particular topic, so it helps you, it gives you more questions or more examples to learn that particular thing. And even more,
Understood.
yeah, even more in health industry, you have applications on health chatbots, and there are digital twins that can be built on persons, and those digital twins tries to give more better responses for doctors as well. So there are these applications and even more industries from anywhere you think of. So everywhere, whenever there is something related to retrieval of information or discussing or chatting with something, so LLMs are there.
Understood. Thank you. Thanks a lot, Vamshi. We had a great time. And I hope all the attendees also enjoyed today's session.